GMAT all day.
One way in which knowing divisibility pays for itself is simply in the form of knowing your divisibility rules. So if you just print this sheet out, take half an hour to commit these to memory so that they are second nature, you will end up saving exponentially more time in terms of cutting down on the time doing arithmetic, cutting down the time you are having to do things on paper, and you will also cut down on the potential for making math mistakes. So the first and simplest divisibility rule, all even numbers are divisible by 2. That is the definition of an even number. The second rule here is, this is the one I probably use more than any other. A number is divisible by 3 if the sum of the digits is a multiple of 3. So if they give you a number like 381 and you're wondering, well, is that prime or not? Is it divisible by anything? Well, if you sum up the digits, they're equal to 12, which means it must be divisible by 3. A number is divisible by 4 if A, you can divide by it twice, or if the last 2 digits form a multiple of 4. So something like 128, because 28 is 4 times 7, therefore 128 must be divisible by 4. Number is divisible by 5 if it ends in a 5 or a 0. It's also true that if a number ends in a 0, that number is going to be divisible by 10. Number is divisible by 8 if the last 3 digits form a number divisible by 8. This rule I use less just because there are less opportunities to use it. You need a number that is at least 3 digits, but you can use this as well. Number is divisible by 9 if the sum of the digits is a multiple of 9. This sort of goes along with your divisible by 3 rule. And lastly, if you add or subtract any 2 multiples of n, the result is also a multiple of n. So something like 12 plus 30. So 12 and 30 are both multiples of 6, so they should give you another multiple of 6, which 42 is. And really all this rule is doing, this is just simply due to factoring, which is also part of divisibility. Because if I have 12 plus 30, just say is equal to something, I can factor out a 6 here. I get 6 times 2 plus 5. The point is it's 6 times some integer. That means 6 times an integer is just a multiple of 6. So the fact that you can factor out a 6 here means the result is going to be a multiple of 6. So let's see if we can apply these rules in addition to the prime factorization rules from the previous video to a problem. This is sort of why divisibility is also so high yield, because they can just ask it in so many different ways. So here they like to do sometimes these 3-in-1 questions, which can be big time suckers, but not necessarily, especially if you can sort of figure out what the question is asking without having to actually test every single one of the options. So they want to know which of the following integers are divisible by 24. So if a number is divisible by 24, it's got to be divisible by all the factors of 24. So 24 is going to be broken down to 8 times 3. 8 is just 2 times 2 times 2. These are prime factors of 24. And so any number divisible by 24 will be divisible by not only all the prime factors, but any combination of them. So it'll be divisible by 3 times 2, 3 times 2 times 2, 3 times 2 times 2 times 2, and so on. So we can start with my favorite divisibility rule. If it's divisible by 24, it's got to be divisible by 3. So we can check that first. So for 192, 1 plus 9 is 10, plus 2 is 12, so that will be divisible by 3. So that works. Divisible by 1024, is that divisible by 3. So if we sum these up, 1 plus 0 plus 2 plus 4 is 7. So 7 is not a multiple of 3. Therefore, this will not be divisible by 3. Therefore, it is not divisible by 24. And anything with a 2 in it, we can eliminate. So 3 out of our 5 answer choices are gone just based on that one divisibility rule. Our last number, 5 plus 1 plus 6, is equal to 12. So that will be divisible by 3. What else then has to be true? Well, it's divisible by 2, so we got to have an even number. Both of our numbers are even. Now maybe we can check our divisible by 4 rule. So that was the last 2 digits have to be a multiple of 4. So is 92 divisible by 4? I think it is. 23. So that works. What about 51 says 60 is divisible by 4? So 60 divided by 4 is 15. So this will be divisible by 4, so it's divisible by 3 and 4. And so can't eliminate any option yet. So we know both are divisible by 3. And two of our 2s. So that gave us our 4. So we really just need to know, are these numbers divisible by 8? So 160, we use our divisible by 8 rule. That definitely works. So we were really done here. We don't even need to test the 192 because 192 appears in both of our answer choices. So if we want to know if 5160 is divisible by 8, we just got to test is 160 divisible by 8. And it is. 20 times 8 is 160. So C is the answer because it's divisible by 8. It's also divisible by 3. Meaning that it must be divisible by 4.